Yeah, listen. Corrosion. Okay, right. So, from the corrosion topic, each set one question will be there. Wet corrosion, dry corrosion. Okay, definitely the question will be there from the corrosion. That question, wet corrosion or dry corrosion. Okay, so first, what is a corrosion? Corrosion means what? Corrosion means what? He is sleeping from the beginning on your phone.
So there are two.
No. First we discuss one by one. What is a corrosion? So now, yes, nowadays corrosion is a very big issue. We have to protect the corrosion, okay, by making the coating or alloying. Okay, it's a way to protect the corrosion. What is a corrosion? Oxidation of metal, destruction of metal. Okay, so definitely the metal exposed to the environmental conditions, it oxidizes the environmental condition and it make a rust. Okay, that is a corrosion. So here the corrosion, yeah, we have to avoid the corrosion because otherwise we should not get the yes. So it decreases the strength of the metal. If the corrosion is continuously happening in our metal surfaces, it decreases the strength of the metal. Okay. And also so many problems is there. What is the effect of corrosion means? It reduces the value of goods due to the loss of appearance, whatever they given, hence the knowledge of corrosion and its control will be help to reduce the loss of metal surfaces. Okay, we have to know about what is the corrosion and its process. Then only we know how to restrict the corrosion, how to protect the corrosion. Okay, so here the corrosion normally will happen in the dry condition and wet condition. So dry corrosion and wet corrosion. Okay, wet corrosion. Dry corrosion means in the presence of air. Okay, in the air itself, oxygen, carbon dioxide, all the gaseous molecules. The gaseous molecule interact with the metal surfaces to oxidize the metal surfaces, hence it reduces the strength of the metal. That is a dry corrosion. And wet corrosion means presence of humidity, moisture. Okay, it initiates the corrosion. That is a wet corrosion. So wet corrosion, otherwise electrochemical corrosion. Okay, wet corrosion, otherwise electrochemical corrosion. Dry corrosion or chemical corrosion. Okay, dry corrosion, otherwise chemical corrosion. Wet corrosion, otherwise electrochemical corrosion. Here electrochemical corrosion, you know the electrochemical corrosion means anode and cathode will be there and electrolyte will be there. In the dry corrosion, there is no anode and cathode reaction, oxidation reduction reaction. Okay, oxidation and reduction reaction. So oxidation, for example, the dry corrosion, the presence of oxygen molecule, what happened there? Corrosion, how the corrosion initiates. Okay, that we will discuss. So oxidation corrosion, that we can say oxidation corrosion. Oxidation corrosion, it means the presence of oxygen gas, O2 gas. You know the O2 gas is there in our environment, so definitely it will affect the metal and it will react the metal surfaces to oxidize that metal into to form a metal oxide, MO. Okay, that is a oxidation corrosion. So for example, if the oxidation air is there, O2 is there, the metal becomes metal 2 plus 2 electron. Okay, 2 electron. So what happens that 2 electron or else number of electrons, if M becomes Mn plus it releases the n electron. Sometimes 2 electrons, sometimes 3 electrons, sometimes 1 electron based on the metal. So here generally we can take a metal. M becomes M2 plus 2 electron. Otherwise Mn plus n electron. Okay, right. So here that n electron it reduce O2 plus 2 electron. Otherwise n by 2 O2 whatever it is to form O2 minus. Okay, 2 O2 minus. Okay, so then finally what happened here? The metal react with the oxygen to form metal oxide. Okay, metal oxide. That is a ultimate reaction, and 2 electron cancel. Metal becomes metal oxide. Okay, metal becomes metal oxide. So this is called oxidation corrosion. In presence of oxygen, the metal oxides to form a
corrosion is dry and wet,
dry and wet corrosion.
Then oxidation corrosion
It
comes under
one of the chemical, one of the gas, oxygen. You know the oxidation means addition of oxygen. Chlorination means addition of chlorine. Okay. So oxidation corrosion means addition of oxygen into the metal surface to form metal oxide. That is a oxidation corrosion. This is in presence of oxygen.
addition of oxygen to
Metal surfaces to oxidize to form a metal oxide. Similarly, the presence of hydrogen also. Hydrogen also is present because H2S gas. That H2S have hydrogen. That hydrogen also interact with the metal surface to form a metal hydride. Okay. Similarly, the chlorine also, Cl2 gas. Okay. That is a corrosive gases. Okay, Cl2 react with metal to form a metal chloride. There it releases there also oxidation is there. That is a oxidation by other gaseous molecule. So this is our everything in the gaseous molecule, right?
So
The
that's half O2.
Where?
Half O2.
Yeah, half O. Otherwise you can take it here M2, M2 plus O2 minus.
There is half O2 in the
No, n by 2 O2. Okay, n is there here. If n2 plus n2 electron, n by 2 O2. Anywhere you can take a ratio. These are all right hand side, left hand side equilibrium. The ultimate concept is MO, formation of O2. This will be varying based on the metal. Fe2 O3, Fe2O2, FeO. Okay, that oxygen, how much moles of metal to comes to metal ion, that much oxygen it react with the metal ion to form a metal oxide. Okay, that is not a problem. That is both sides you can equate. Ultimate aim is formation of metal oxide. That is the concept. Okay, metal oxides to form a metal oxide. Right, this is a oxidation happened by the presence of O2 gas. O2 gas. So here you know what happened. If you have to explain the stepwise means, you know first the fresh metal surface is there. Okay, this is a fresh metal surface. Suppose you can take the iron pieces means this is a fresh metal surfaces. So these fresh metal surfaces is exposed in the oxygen environment. What happened here? The oxygen environment it absorbed on the metal surfaces. Right? Here interaction is there. O2 is there. So what happened? The metal immediately it released the 2 electrons to become M2 plus. Okay, M2 plus. Immediately what happened? The metal oxide Fe means here Fe2O3 dot H2O, that is accumulated on the surface of metal. So here, so continuously the destruction will be there in the metal surface. So lot of corrosion is there, pitting corrosion, differential aeration corrosion, stress corrosion, okay, everything. So this is how the oxidation is happening in the metal surface. Pure metal, if it is exposed in the oxygen environment, means to interact the oxygen into on the surface of metal, that metal to immediately release the 2 electron, because that is a acceptor is ready, so donor is there, it donates the 2 electron to form a metal oxide. Okay, metal oxide. Based on the formation of the metal oxide, nature of the metal oxide, metal oxide cover on the metal surfaces. What is the product is there on the metal surfaces? Based on that, the corrosion is further continued, or else the corrosion is stopped. What happened? That we discuss. So, for example, the nature of the oxide film formed on the metal surfaces play the main role for the continuation of the corrosion. For example, you know the stable oxide layer. That means if you are taking the metal surface here, okay, metal surfaces, it react in the presence of oxygen environment. Here the oxide layer is formed on the metal surfaces. It covers fully on the metal surfaces. So what happened here? There is no fresh metal surface is there, is not there. Therefore the oxygen is not interact with the metal surface to further oxidize, because already it covers the metal oxide on the surface of metal. So for example, aluminum, you know the aluminum is there to carrying the electric, right? So that aluminum is not corrode easily, because the aluminum, once it reacts with oxygen to form a Al2O, right? Aluminum oxide cover the metal surface, that aluminum surface, that metal oxide itself restricts further corrosion. If it is iron pieces, means you know the iron pieces, continuously the corrosion is happen on the metal surfaces. Okay, because that is an unstable oxide layer. This is a stable oxide layer. The oxygen is formed on the metal surfaces, that is stable oxide layer, or else non-porous oxide layer. It means it covers the metal surfaces, fully it covers the metal surface. It won't allow the environmental oxygen to interact with the fresh metal surfaces to form a metal oxide. It won't allow. That is a stable oxide layer, or else that is called non-porous layer. That is called non-porous layer. Okay, non-porous layer. Example, aluminum, lead, tin, copper, even copper also. Copper, tin, these are all formed the stable oxide layers, which means the metal oxide is covered fully on the metal surfaces. That metal oxide, it won't allow the environmental oxygen into the interior metal surfaces. Therefore, it restricts the further corrosion. Okay, further corrosion. You got it? That is a stable oxide layer. If you want, I dictate. The formation of impermeable, no, that is a concept. Okay, next, unstable oxide layer. Unstable oxide layer, or else porous layer. Porous layer. You know what is a porous layer means? The same. You take a fresh metal surfaces. If you keep the oxygen environment, the metal oxide is there, but that metal oxide will form a porous layer. That means always the fresh metal is available on that metal surfaces. That fresh metal react further in the oxygen environment to oxidation, continuous process. Oxidation is a continuous process up to the metal completely exposed, completely exhausted. Okay, up to that the corrosion is continued. That is a unstable oxide layer or a porous oxide layer. You know the iron pieces is there. You can kept it in the outside. The corrosion product is there. Once you remove like this, all the corroded product. Okay, again fresh metal surface is there. But in the aluminium, you take aluminium. Yes, metal oxide is there. Some the black color dot is there in the aluminium. Okay, that aluminium oxide, it won't come out from that metal surfaces. That is a non-porous layer. This is a porous layer.
So why does not porous not come out?
That's what porous means. Fresh surface is there. It allows that environmental oxygen to contact the fresh metal surfaces to form a metal oxide. But here it covers fully the metal surfaces. It won't allow the environmental oxygen to contact with the metal surfaces. That is a non-porous layer. You know the porous layer, example, our iron, silver, platinum, okay, iron, silver, platinum, these are all form of porous layer. Porous layer, that means corrosion is continuous process up to all the metal exhausted. The corrosion is happened. We have to restrict the corrosion. To stop the corrosion means, that's why we make a coating. We make a coating on iron surfaces. Okay, but in the aluminium we should not make a coat. For the decoration maybe we can make a coat, but that coating is not to stop the corrosion. Nowadays the aluminium also to make a coating, that is for only the decoration, color, different color view. Okay, everywhere the aluminium only is there. Okay, that coating is only for the decorating the metal surface. It's not stop the corrosion process. But in the iron metal, we make a coat that is to protect the corrosion, or else to protect the metal surface into the environmental contact, to restrict. That's why we make a coating. Okay, right. The next one is volatile oxide layer. Volatile oxide layer. Volatile oxide layer means if the fresh metal surface is there, okay, fresh metal surface, it react, or else it environmental contact oxygen is there, means continuously the corrosion is happened. After one particular time, there is no metal. Immediately it exhausts. The oxide layer, whatever the oxide layer is formed on the metal surfaces, this oxide layer is a volatile nature. Volatile nature. Immediately it evaporates into the environment. Okay, that is a volatile oxide layer. Example, molybdenum. Definitely they ask the question, what is a volatile oxide layer? Example of metal. Molybdenum oxide. Molybdenum oxide is a example for volatile oxide layer, because the molybdenum oxide is it's quickly evaporate in our environment. Okay, molybdenum, MOO3. If it reacts with oxygen to form, okay, volatile oxide layer. So the molybdenum metal to form a MOO3, that is volatile nature, therefore the molybdenum metal exhausted quickly. Okay.
Is it over? Corrosion?
Corrosion? Corrosion over. No. Now we discussed only the one dry corrosion only we are discussing. In the dry corrosion also only the oxygen interaction we are discussing. Similarly, the other gaseous molecule also is there. This one we call the Billing-Petworth ratio. This is a Billing-Petworth ratio. What is that? Stable, unstable, volatile nature. This is a Billing-Petworth ratio. Billing-Petworth ratio, which means volume of metal oxide is greater than the volume of metal. For example, here the volume of metal oxide greater than the volume of metal, that is form a non-porous layer. The volume of metal oxide is less than the volume of metal, that is form a porous layer. Okay, porous layer.
Sir, stable, unstable, volatile oxide all are under piping.
What you are saying?
What is the piping?
Billing-Petworth ratio, which means the stable oxide layer or else non-porous layer. When it form a non-porous layer, volume of metal oxide is greater than the volume of metal. Volume of metal oxide is greater than the volume of metal. So here more metal oxide is there. That metal oxide is covered fully on the metal surfaces. Therefore, it restricts the further corrosion. That is a form of stable oxide layer. That is Billing-Petworth ratio. Stable oxide layer. Okay, that is one rule. Another rule is the metal oxide is less than the volume of metal, means that time it form a porous layer. Porous layer or else unstable oxide layer. That is also everything. 1, 2, 3. All 3 is the Billing-Petworth ratio.
Sir, what is the spelling?
Billing, Billing, Bedworth. Bedworth. Billing-Petworth ratio or else Billing-Petworth rule. Billing-Petworth rule says volume of metal oxide is greater than the volume of metal. What is that? Similarly, volume of metal oxide less than the volume of metal. What is that? Okay.
Sir, can you show me the
Okay. So this one, everything by in the presence of O2. In the presence of O2. Similarly, we go for the other gaseous molecule. For example, you know very simple. That is metal react with Cl2. That is, you know the Cl2 environment, corrosive gaseous environment means it form a metal chloride. Right? Metal chloride. Similarly, the presence of hydrogen, H2 environment. You know the H2 environment immediately produce the H atom, that is hydrogen atom. That hydrogen atom it occupies the voids of the metal. Wherever the voids is there on the metal surfaces, it go and occupy that hydrogen radical in that voids of the metal. So that hydrogen radical continuously it increasing the H dot, means H dot react with H dot to form a hydrogen gas. That hydrogen gas, volume of hydrogen gas is increasing continuously. It breaks the metal surfaces. That incident is called hydrogen embrittlement. Okay, hydrogen embrittlement. That I can say here. See, for example, you know the H2S. H2S we are using. So there it produces the H dot. Okay, H dot. So that 2H dot. 2H dot react with metal to form wherever the Suppose here the metal is there, okay, the metal is there. Definitely the metal means some voids is there, some pores are there in the metal surfaces. That pores itself is enough, the H dot to occupy in that pores. So therefore hydrogen H dot continuously occupied in the voids of the metal. So what happened? It react together to form a H2 gaseous molecule. That H2 gas is occupied their voids continuously. So it increasing the concentration of H2 gas means it breaks the metal surfaces. That is called hydrogen embrittlement. Got it? Hydrogen embrittlement means the metal surface break in the presence of H2 gas. How the H2 gas formation on the metal surfaces? The H dot. How the H dot is formed? If you keep the metal in the hydrogen environment, that is the H2S gas. So we are discussing the chemical corrosion only. So gaseous molecule presence, what happened to metal? So O2 means what happened to metal. Cl2 means what happened to metal. Similarly, H2 means what happened to metal. Okay. So in the H2 means the hydrogen embrittlement incident is happening in your metal surfaces, but the other gas it won't do like this. Only the hydrogen embrittlement because of presence of formation of H2 gas. Okay, formation of H2 gas. Okay, formation of H2 gas. Similarly, the bed corrosion is there. They ask the question maybe, what is hydrogen embrittlement? Hydrogen embrittlement. Hydrogen embrittlement means the metal surface break in the presence of H2 gas. In the presence of H2 gas. Time is there? 2:05 only. She is saying always 5 minutes extra.
Sir, my watch is 5 minutes extra.
Right? Maybe wet corrosion we take tomorrow and 4 points diagram also. Otherwise, I initiate the wet corrosion. Next class we will discuss wet corrosion continuation in 4 parts. So next is this one up to oxidation corrosion. If they ask the question, explain the dry corrosion or explain the chemical corrosion means you have to write it. What is a oxidation corrosion and what is a Billing-Fedworth rule and what is influence of other gases. That means presence of H2 what happened, presence of Cl2 what happened, everything. Okay. Next, wet corrosion. You know that wet corrosion. Wet corrosion means, you know the wet corrosion, there the reduction and oxidation it happen in your dry corrosion. In wet corrosion, the separation of anode and cathode will be there. Okay, separation of anode and cathode will be there. Here the electrolyte is must. You know the electrochemical corrosion means definitely the electrolyte is play the main role to carrying the electron from anode to cathode. So which one is carrying the electron from anode to cathode? Only the electrolyte. Okay, only the electrolyte. So wet corrosion, for example, you can take any metal. There the two incidents happen. One is the evaluation of hydrogen, another one is the absorption of oxygen. Normally, you know the wet corrosion means similarly metal becomes metal to Mn plus N electron. That is anodic reaction. At the anode, what happened? Metal becomes metal 2 plus N electron. And the next one is a cathodic reaction. Based on the cathodic reaction only, we can separate in two types for the wet corrosion. One is a evaluation of hydrogen gas, another one absorption of oxygen. Okay, first Evaluation of hydrogen. That means when the hydrogen evaluation reaction, you know the presence of acidic medium. The corrosion is happening in the presence of acidic medium. The corrosion is happening in the presence of neutral medium. But in the corrosion, it won't happen in the presence of basic medium. Because OH minus, already the minus is there, then how the metal surface to release the electron? No, it won't accept the minus charges. Therefore, it restricts the corrosion when in the presence of basic medium. So only the corrosion is happen either neutral medium or else in the acidic medium. In the acidic medium, that is a hydrogen evolution reaction. In the neutral medium, that is a adsorption of oxygen. Okay, hydrogen evolution reaction, evolution of hydrogen. For example, we consider only for the iron, the same metal you can take it. Okay, metal you can take it. Suppose for example this iron surface means okay iron metal. So here that is a cathode. Suppose the acidic environment here, the small H2 or HCl is there, this acts as a anode. Okay, this acts as a anode. So here what happened that the anodic side Fe2 becomes Fe2 plus 2 electron. That 2 electron what happens? It travel from here to here, there, the H plus ion to accept 2 electron to form a H2 gas. This is a cathodic reaction. Okay, cathodic reaction. That means in the anode side, Fe becomes Fe2 plus 2 electron. That is a anodic reaction. Anodic reaction. In the cathodic reaction, what it is there? HCl or else acidic environment. Acidic environment means you know very well H plus ion is more. When the H plus ion is more, means it is ready to accept the electron. Here the metals donate the electron. Therefore, at cathodic reaction, what happens at cathode? Cathode, what happened? 2H plus accept that electron, that whatever the release the electron to form a H2 gas. H2 gas. So finally the net reaction is Fe to react with 2H plus to form a Fe2 plus, that is then H2 gas. Okay, H2 gas. So this is a evolution of hydrogen gas. From that H2 gases is coming out. Okay, the metal itself separate the anode and cathode where the droplets of that acid molecule is there. That area act as an anode, the rest of the area act as a cathode. In the anodic area, the metal release the electron. In the cathodic area, accept the electron to form a gaseous molecule. Here, acidic environment, therefore hydrogen gases is coming out. Yeah, acidic environment means H plus HCl, acidic acid, like that environment. Okay. So wet corrosion means you have to explain what is a wet corrosion and you have to explain what is anodic reaction, cathodic reaction with the diagram. All two types, evolution of hydrogen as well as adsorption of oxygen. They move. Next one is adsorption of oxygen. Adsorption of oxygen. You know only two environments. One is the acidic or neutral environment. In the neutral environment, adsorption of oxygen is there. In the acidic environment, evolution of hydrogen. In the neutral environment, you know the H2O only are there. Neutral means only the water molecules. So in that H2O, what happened? Similarly, for at the anodic site, the same reaction at the anode. At the anode, what happened? The Fe becomes Fe2 plus 2 electron. That is an anodic reaction. And in the cathodic reaction, at cathode. So cathode, what happened? Dissolved oxygen also is there, and the water molecule also is there to accept the 2 electron. To form a OH minus. And finally, you get the Fe to react with environmental oxygen, that is a dissolved oxygen, in the presence of H2O to form a Fe2 plus OH minus. Otherwise, FeOH. Anyway. Okay. As per the mole ratio, you can write it 2OH minus OH minus whatever. This is a neutral medium, because neutral medium, you know, water molecule is there and O2 is the dissolved oxygen. Okay, that O2 and the water molecule accept that 2 electron which one is released from the anodic side to form a hydroxide ion. So net reaction is ferrous hydroxide formation. That is a adsorption of oxygen adsorbed on the metal surfaces. Then it reacts with the water molecule plus whatever the electron released from the metal to form a hydroxide ion. So at final net reaction is formation of metal hydroxide. So this is a wet corrosion. So it won't stop the further. Again, the further corrosion is continuous up to formation of the complete rust. That is Fe2O3 dot 3H2. Okay, 3H2 dot 3H2. Up to the formation of Fe2O3 dot 3H2O, the corrosion is continuous. That is a rust formation. Okay. Sometimes they ask the formula. What is the formula of rust? Okay, Fe2O3 dot 3H2. Right? Yes. Today's class is fine.
So till